Assalamu alaikum. I am your host Muhammad Shiraz. Welcome to the 21st program of Computer Programming Concepts. Dear students, in today's program you will study about a very important concept of programming language C, that is pointer. In earlier programs you learned how to declare variable and how to access variable. You learned that a variable contains a value of a specific data type, and when you declare a variable, some memory space is reserved for the variable according to the data type. 2 bytes memory space is reserved for variables of integer type. 4 bytes memory space is reserved for variable of float type, and 1 byte memory space is reserved for variable of character type. A variable is a name through which we can access that memory location reserved for the variable. We can say that when you declare a variable, then 3 things happen with the variable. So memory space is reserved according to the data type of variable. An initial value is assigned to that memory location, and there is an address to that memory location. But normally we do not access the address of the memory location. We access that memory location by using the name of variable. In today's program you will learn how to access the memory location of a variable by using the address of that memory location. So pointer is basically a concept or a mechanism through which you can access memory locations of a variable indirectly. So let's start today's discussion. What is pointer? A pointer is a mechanism for accessing memory location of a variable indirectly. When a variable is initialized, memory space is reserved for it. For example, we use the statement int x equals to 0. In this statement, name of the variable is x, data type of x is int, and initial value of x is 0. 2 bytes memory space is reserved for x because the data type of x is int. Memory space will have some address. Ampersand symbol is used to return address of the variable. This is a simple example. In this example, we have declared a variable x, initialize it to the initial value 0. Printf statement will display the value of x, that is 0. This printf statement at line number 4 will display the address of the memory location of x. In order to access the address, we put the ampersand symbol before x. It means this is called value at address operator. And then the statement at line number 5 is a bit surprising. In this statement we have used ampersand x. Ampersand x will return the address of x and static address. This static operator will display the value at this address. Let's exercise this example on the computer. This is the same example. Suppose we are initializing x to the initial value 10. Now compile the program, there is no error, and see the output. In the first statement we have displayed simply the value of x, so the statement displayed the value of x is 10 as we initialized x to the initial value 10. Then address of x is, this is address of x, that is automatically assigned by the operating system, and whatever is the address of the variable, it is returned by the ampersand symbol. And then in the following statement we are accessing the value at that address. We first used ampersand x will return the address 65524, and then static 65524 will display the value at this address. It means in order to access the address of a variable, you need to use the ampersand symbol. Pointer variable. Pointer mechanism is implemented by using pointer variable. A pointer is a variable that holds the address of memory location. As I told that the mechanism pointer is basically implemented by using pointer variable. Now what is pointer variable? It is a sort of variable that could hold the address of a memory location. In this example, we have declared a variable y of type int, then we declare a pointer variable int static x. You should remember that pointer variable is declared with a static symbol. In this statement, static x is pointer variable. You may declare pointer variable with any name, and you should also remember that the data type of the pointer variable means that this pointer variable will hold address to the value of this data type. Normally, the data type of a variable means that this variable will contain a value of this type, but the concept is a bit different with the pointer variable. The data type of the pointer variable means that the value of this pointer variable will be an address of the value of this data type. You should remember that the value of a pointer variable is always memory address. You cannot assign normal values to the pointer variable. Pointer variable is specifically for holding memory addresses. Now then what does the data type of the pointer variable means? Because all the memory addresses are of the same data type. They do not have float, character or an integer type. They are constant of the same type. So the data type of the pointer variable means that this pointer variable will contain the memory address of that specific data type. Here in this example, static x means that x is a pointer variable that may hold memory address of that value whose data type is int. Then we initialize in this example y2123. Suppose this is memory map, and we assume that this is variable y. It is stored at memory location 300. The value assigned to this memory location is 123, is shown in the figure. Now it should be clear to you people that this is the name of variable, this is memory space reserved for the variable, this is the value stored at this memory location, and this is the address of this memory location. You simply access this memory location by using the name of variable. That's why in earlier programs we defined a variable as a name given to a memory location. So we can say that variable is just used to access that memory location that is reserved for that variable. Okay, then in this example we are initializing x with the address of y. As I told earlier, in order to return the address of a variable, we put ampersand symbol before it. Now here I want to initialize x with the address of y. That's why I used x equals to ampersand of y. This statement ampersand y will return the address of y, which is considered in this case as 300. So x will be initialized to 300, and this 300 is not an integer value, this is the memory address of the integer variable y. You should also notice that a pointer variable by itself is a variable. When you declare a variable, memory space is reserved for it, there is an address to the pointer variable as well, and there is a value to the pointer of the pointer variable as well. But the value of the pointer variable will always be the address of a memory location. So here in this example, the pointer variable x is initialized with the address of variable y. In this example, x is the pointer to an integer, x is called a pointer variable. Pointer variable is declared with static symbol, and the variable may be composed of any characters. The name of pointer variable can be any valid variable name. It should follow rules for naming a variable. Int x means that x will hold address of an integer variable. The value of pointer variable can be an address of the memory location. The data type of the pointer variable represents the type of address that the reference variable can hold. Integer reference variable or pointer variable can hold memory address of integer values only. Float variable can hold address of float values only. Pointer variable is always initialized with the address of any other value of the same data type. Suppose int static x comma y. In this example, static x is a pointer variable and y is a simple variable. Now here y is initialized with the initial value 50, memory address of the y is assumed to be 300, and this is variable x, it's a pointer variable, it is initialized with the address of y that is considered to be 300 in this case. In C language, you can get the address of a variable with the ampersand operator. Int y equals to 1, 2, 3, and x equals to ampersand y. X hold memory address of y. We can access values stored at y using static operator with x. You should remember that once you initialize a pointer variable to the address of another variable, then pointer variable has complete access to that memory location. You can simply access the value stored at that location, you can change the value at that location, and you can use the value stored at that location by using pointer variable. We will study all these concepts through examples in a discussion later on. Here in this example, x holds memory address of y, as x is a pointer variable. We can access the value stored at y using static operator with x. That is, when we use simple x, it will return the value of x, that is the address of y. But when you use static x, then it means the value stored at this address. That is, static x means that value stored at the address pointed by y. So the value stored at this address is 50. So whenever you want to access the value stored at address through the pointer variable, you simply use static operator with the pointer variable. Assigning a value to dereference pointer. A pointer must have a value before you can dereference it. In static x and static x equals to 3, this is an invalid statement. It is because x is a pointer variable, which means that x could hold the address of integer values only. You cannot initialize a pointer variable to a normal value, while in this statement we are initializing pointer variable x to the initial value 3. Therefore, there is an error. While when you declare an integer variable foo and then in static x, x equals to ampersand foo, this is a valid statement. This statement will assign the address of variable foo to x. Now x has complete access to the memory location of foo. While using static x equals to 3, this statement is a bit confusing. You should remember that here we are not assigning 3 to the variable x, as static x is pointing the address held by x. So the address held by x is the address of foo, and static x means the value at foo. So static x will change the value of foo to 3. This is fine, x points to foo. Let's study another example of pointer. In this example, we have declared a pointer variable static x. You should remember that it is not necessary to name the pointer variable as x. You may use any valid variable name with the pointer variable, and then a simple variable y has been declared over here. Then we are initializing y equals to 50, x equals to ampersand y, will initialize the pointer variable x to the address of y as shown in the diagram. Ampersand y will return the address of y, that is assumed to be 300, and thus x is initialized to the value 300. Then value equals to %d, and we are displaying the value of y. Then address equals to %u, and then we are displaying ampersand y. You should notice that address of the memory location is always unsigned, that is always positive, it can never be negative. That is why we use the format specifier %u for positive only values. It means unsigned value. So the address of the memory location is unsigned, that is why we use %u for displaying the value of the address. In the next statement, we are displaying the address and value of x, that is basically a pointer variable. Value equals to %d, it will display the value of x, and the value of x is 300, that is address of y, and then the address of x is ampersand x, that will display 500 or any address assigned to the pointer variable x. And then the statement at line number 8, value at static x is %d, it will display the value at address held by x. Let us exercise this example through the computer screen. Static x pointer variable, this is y initialized to 50, and this is x initialized to ampersand y. Printf is displaying the value of y, and this %u will display the address of y. Similarly, this x will display the value of x, and %x will display the address of x, and static x will display the value held at address. This is the output. Let's make it more clear by changing the line each time. That is, value of y is 50 and address of y is 65522. It is designed by the operating system. Then value of x is basically an address, that is why we will have to use the format specifier as %d. So this is the value of x, that is basically address of y, and address of x by itself is this one. And then the value at static x is 50. You should notice that static x is accessing the value stored at y. So static x will give the same result as y, because this time x is a pointer variable that has held the address to y. So in that case we will receive the same output regarding to our example. Address of y, value of x is 300, that is address of y, and value of x is 500, that is its own address and value at static x is 50. A pointer variable can be of any type. You should remember, when you declare integer pointer variable, it can hold addresses of integer value. When you declare double variable, double pointer variable, it can hold address of double variables. When you declare character pointer variable, that will hold address of character values. So x is a pointer variable that will point some int, z is double that will point some double value, and c is character that will point some character. And this is a bit amazing declaration in static y. This is called pointer to pointer. It means y is a pointer variable that will hold address of a pointer variable of integer type. So now the pointer variable y is called a double pointer or pointer to pointer. It will hold memory address of a pointer variable. You cannot assign the address of a simple variable to the pointer to pointer variable. Now you see in the diagram that y is pointing some pointer integer variable, and that is then pointing some integer value. X is a pointer to an integer. You can use the integer x points to int in C expression like this: int y equals to 5, int static x equals to ampersand y. You may initialize pointer variable in its declaration as well, as shown in this example. We are declaring pointer variable and we are initializing it in its declaration as well. So here the initial value of y is 5. Now y equals to static x, that will give access to the memory location of y. Static x will return 5 plus 17, and then 5 plus 17 will return 22. So the value of y will become 22 after this expression. The int x points to y. We may also use static x equals to static x plus 1. This statement will also basically change the value of y, as static x means the value at address hold by x, that is basically y, equals to its current value plus 1. So current value is 22 and plus 1 will make it 23. Let's study an example. In this example, there is a simple variable y initialized to 5 and a pointer variable static x. X is initialized to the address of y, then static x equals to static x plus 5. Static x means the value at address hold by x. So the address hold by x is the address of y, therefore static x will return the value of y, that is 5, 5 plus 5, 10. Then static x, the value at address hold by x will become 10. That's why printf \n value of y is, now the new value of y, that is 10, is accessed, and then y equals to y plus 3, its new value will become 13, and when we access it by using pointer variable, we will get the new value of x. Let's exercise this example on the computer. This is the same example. Let's execute it. You see the value of y is initially 10, but we have initialized y to 5. From where does the value of y get changed? It is by using pointer variable static x equals to static x plus 5, and then we changed the value of y by y equals to y plus 3, and then by accessing that value by using static x, we are getting exactly the same value from the same location, and then value of y equals to 13. So dear students, in today's program you learned about pointer. We studied that pointer is a concept, is a mechanism for accessing memory locations indirectly. You learned how to declare pointer variable, how to initialize pointer variable, and how to access the memory locations indirectly by using pointer variable. We will study some more concepts regarding pointer in next program inshallah. It is very necessary that you should carefully study the concepts studied in today's program, and you should exercise all these examples and many other examples by your own, because practice will make your concept complete. We will meet with a new topic in next program inshallah. Till then, Allah Hafiz.